Welcome to qnawire.
In this question, it is given that in an insulated container, refrigerant R134A is filled and the volume of this container is 0.2 meter cube. The pressure is 500 kilopascal. This refrigerant is in saturated vapor state and the flow stops by itself. We are required to calculate the final mass and the temperature in the container, and then we need to find total irreversibility in this process. So let's see how to solve this question. Since the container is insulated, therefore heat transfer Q during process 1 to 2 is equals to 0. There is no work done and no work is received, therefore work transfer during process 1 to 2 is equals to 0. And initially there is no mass, so we can write m1 is equals to 0. Now let's apply the continuity equation. So we can write m2 minus m1 is equals to m in. Now let's substitute the value of m1. So we can write m2 minus 0 is equals to m in. Now let's apply the energy equation. So we can write m2u2 minus m1 u1, and this will be equals to m in into h line. Since m1 is equals to 0, therefore we can write m2 u2 is equals to m in into h line, and since m2 is equals to m in, therefore we can write u2 is equals to enthalpy line. Now let's apply the entropy equation. So we can write m2s2 minus m1s1, and this will be equals to m in into s line plus 0 plus s generation during process 1 to 2. Now m1 s1 will be equals to 0, so we can write m2 s2, and this will be equals to m in into s line plus entropy generation during process 1 to 2. Now refer table B.5.1. So from there we can write H line is equals to 407.45 kilojoule per kilogram, and S line is equals to 1.7198 kilojoule per kilogram Kelvin. Now let's write the properties from the steam table corresponding to state 2. So we can write P2 is equals to P line and U2 is equals to H line, and this will be equals to 407.45 kilojoule per kilogram, which is greater than Ug, and the temperature corresponding to this enthalpy and internal energy is 40 degrees centigrade. So this is the final answer for the final temperature. And now let's write other properties. So we can write V2 is equals to 0.04656 meter cube per kilogram, and S2 is equals to 1.7971 kilojoule per kilogram Kelvin. Now let's apply the formula to calculate mass m2, and this will be equals to capital V upon small v2. Now let's substitute all the values. So we will have m2 is equals to 0.2 divided by 0.04656, and this will be equals to 4.296 kilogram. So this is the final answer for the mass. And now let's calculate entropy generation during process 1 to 2, and this will be equals to m2 into s2 minus s line. Now let's substitute all the values, so we can write entropy generation during process 1 to 2, and this will be equals to 4.296 multiplied by 1.7971 minus 1.7198. So when we further calculate, we get 0.332 kilojoule per Kelvin. Now let's apply the formula to calculate irreversibility, and we know that it is equals to ambient temperature T0 multiplied by S generation during process 1 to 2. Now let's substitute all the values, so we will have irreversibility is equals to 298 multiplied by 0.332. When we further calculate, finally we get irreversibility is equals to 98.95 kilojoule. So this is the final answer for this problem. I hope you understood the solution. Thank you.